So in the last video, we talked about how you can graph a polynomial function if it's already in factored form. Today, we're going to look at how to put it into factored form if it's given to you in standard. So let's do an example. Let's say I have f of x equals 4x cubed plus 12x squared minus x minus 15. So what we have to use is the factor theorem. Okay? And the factor theorem states that when you have f at k equals 0, you could say that therefore x minus k is a factor. Now let's think about this for a second, what this means, right? So if you plug in a particular value for x, like let's say I plug in the value x equals 1, right? So I plug in 1 for x, and this whole thing turns into 0. Well, that means that at the point x is 1, you have a y value of 0, which means that's an x-intercept, right? So what we're trying to do is find a value for x that gives us a y value of 0, right? We're trying to find the x-intercept. So of course this makes sense, right? And then one of those roots would be x minus that number, because we always have those x-intercepts sort of baked into the factors. So this should make sense, right? Now this is also related to what we call the remainder theorem, and I have a video on that you should also check out. But for now, let's use the factor theorem to factor this polynomial here. So what do? Well, we have to look first at all the factors of the first coefficient, the 4. What are all the factors of 4? Well, you could have plus or minus 1, 2, and 4, right? Then you look at all the factors of the last number, the negative 15. What are all the factors of negative 15? Well, you have plus and minus 1, 3, 5, and 15, right? Now what we have to do is, between this set of numbers and this set of numbers, make some fractions, okay? So we're going to do these numbers on the right divided by the numbers on the left. So for example, you're going to have 1 over 1. So, and I'll just put plus and minus for these. I'm not going to write the plus and the minus for each one. So 1 over 1, 1 over 2, 1 over 4. Okay, then you'd have 3 over 1, 3 over 2, and so on. I'm not going to write all these out, right? But you have a whole bunch of these numbers here. These numbers that I've written down here, these are all candidates for one of the roots, right? We can find one of the roots by picking one of these numbers, plugging it into the function, and seeing if it equals 0, right? So these are the candidates that we're going to look at. Now, this is what's called the rational zero theorem. Okay? This is the rational zero theorem, what I'm doing right here. So you take the factors of the last number, divide them by the factors of the first number, and those are your candidates for potential roots. Okay? So what we always do is we always start with the easiest one to plug in. Like 1 over 1 is just 1. So I'm going to start with 1, plug it in, and see if it equals 0, right? That's the idea. So let's actually do that. Let's figure out f at 1. F at 1 is going to equal 4 times 1 cubed plus 12 times 1 squared minus 1 minus 15. Okay? So what you end up getting is 4 plus 12 minus 1 minus 15. That's 16 minus 16. That's 0. Oh, great. So we got 0 as an answer. That's good news for us. That means that 1 is going to be a root, right? 1 is going to be one of our x-intercepts. So therefore, I could say that x minus 1 is a factor, right? Because if 1 is a root, then x minus 1 has to be a factor when we go to factor this, right? That's good. That's perfect. That's exactly what we want. So always start, when you're looking at these candidates, at the easiest numbers to plug in first, just to save you time. So you try 1. If 1 doesn't work, try negative 1. You know, if negative 1 doesn't work, maybe go to a half, or maybe go to another whole number like 3 over 1, right, which is just 3. You know, you want to use that kind of strategy to plug in easy numbers first. And then if those don't work, then okay, try a half or negative a half, or, you know, whatever. But usually you'll get a nice easy number in there, at least one of them, right? Because all we need is to find one root. We don't have to find all the other ones using this method. So let me show you what we do next. Once you have one of the factors, we could say that, all right, f of x, which is currently equal, if you remember, to 4x cubed plus 12x squared minus x minus 15. When you factor that, it's going to equal x minus 1, because that's one factor, multiplied by what? Well, we got to figure that out. This is a cubic, right? It's a third degree polynomial. If you factor out a term here with just x to the 1, then the thing you're left with is going to be x to the 2, right? Because x times x to the 2 is x cubed. So the thing that's in here is going to be some trinomial, 4x squared plus a bunch of other terms. I say 4x squared because when you do x times 4x squared, you get 4x cubed. So I'm pretty sure that's going to be the first term. And then you're going to have a couple others, right? So this is going to be a trinomial that we're able to factor, right? So if I can figure out what this is, I can just factor it the old-fashioned way, right? The way we've been doing it in grade 10 and grade 11. And so that's what I got to find out, is what goes in that bracket. Well, if you think about it, if this times this is this, then I could find this unknown here by dividing these, right? I could do this divided by this to get this unknown, right? So that's what we're going to do. We're going to do some division, and we're actually going to use long division, all right? So I'm going to set it up like this. I'm going to say I have 4x cubed plus 12x squared minus x minus 15 divided by x minus 1, just like that. So this is where we get to practice some long division. So this is how we do it. So try to keep up and follow along. I say, how many times does x go into 4x cubed? Or in other words, what's 4x cubed divided by x? Well, that's going to be 4x squared. So I put 4x squared on top, and I put it here, not here. I'm putting it over here on the right because I want it to be in the column that has the other x squared values, right? I want everything to be nicely organized. So you do that, and then you say 4x squared times x minus 1, and you get 4x cubed minus 4x squared. So I'm just multiplying this by this whole thing and writing my answer here, okay? Next, we're going to do some subtraction. So I'm going to subtract these two rows here. So 4x cubed minus 4x cubed is 0. You should always get 0 here because these should be the same term. And then 12x squared minus negative 4x squared. So that's like 12x squared plus 4x squared. That's going to be plus 16x squared, okay? Now we repeat the process over. I say, how many times does x go into 16x squared? Or in other words, what's 16x squared divided by x? And you're going to get plus 16x. Okay? Now I'm going to multiply. And actually, before I do that, I'm going to bring down this negative x, just so I have something to subtract by later. So now I'll do 16x times all this, right? We're just repeating the process. 16x times x minus 1 is 16x squared minus 16x. And we're going to subtract those two lines. 16x squared minus 16x squared is 0, right? And again, you should always get 0 there. And then negative x minus negative 16x, that's the same as negative x plus 16x, which is going to be plus 15x. Okay, now how many times does x go into 15x? Or what's 15x divided by x? Well, you're going to get 15. Multiply those. 15 times x is 15x. 15 times negative 1 is minus 15. And make sure you bring this down just so you have something to subtract by, right? Now we will subtract these two lines. And as you can see, because those lines are the same, you're just going to get 0 and 0. So that 0 at the end represents your remainder. So we have a remainder of 0, meaning that x minus 1 goes into this perfectly. It goes in this amount of times. And that makes sense because if you recall, we determined that x minus 1 was a factor. So there should absolutely be no remainder here at the end. If there's a remainder here, it means you made a mistake, right? At least for this type of question, if you get a remainder, that means you made a mistake because x minus 1 should go into this perfectly with no remainder, right? Now the answer is on top, 4x squared plus 16x plus 15, meaning that you can put it here, right? Because this divided by x minus 1 was that. So that means that x minus 1 times that answer is that original thing. Okay, hopefully that makes sense to you. Now, we have to finish factoring this. And to do that, we just have to factor this bracket on the right, which we can do. It's just a trinomial. We're going to use decomposition, okay? So let me skip down here so I have some space. So we have so far x minus 1, 4x squared plus 16x plus 15. So for decomposition, we do 4 times 15, and that's going to give you 60. So I want to multiply to 60, and I want to add to the middle number, which is 16. And this one should jump out at you, the answer, right? It's going to be 6 and 10. So you decompose that middle term, so you get 4x squared plus 6x plus 10x plus 15. And then the x minus 1 is still there on the front, of course. And then you factor by grouping. So you group the first two terms, so you can take out a 2x and you're left with 2x plus 3. And these two terms you can take out a 5 and you're left with 2x plus 3. And you can do that work on the side if you want, or you can do it here with everything else, up to you. But you're going to be left with 2x plus 5, 2x plus 3. There you go. So if you need to review factoring by decomposition, hopefully this is good enough. If not, go back and watch the factoring videos. Now, it's fully factored, right? We have 3 factors here. None of them can be factored any further. So that's it. Now, with those 3 factors, we can find the roots, right? We know x equals 1. This one here will be x equals negative 5 over 2. So just set this to 0 and solve for x. This one as well. You'll get x equals negative 3 over 2. So with all those points, we can go ahead and plot what we got. So over here, negative 5 over 2, that's like negative 2.5, right? Negative 3 over 2, that's negative 1.5. And then you have positive 1. So you got these 3 roots just like that. It's a positive, right? Because the number on the front was positive 4. So it's going to be going up over here. It's also a cubic, right? It's a cubic function. So it's going up like that. It should be going down over here like that. So you just connect the dots like this. They all have the multiplicity of 1 or the order of 1, right? So they all just cross in the normal way. So it just goes like that. And then you're done. Now, a lot of people have trouble with the long division. If you don't want to do the long division, there's an alternative to it. I'm going to show you that right now, and it's called synthetic division. Okay, so if you want to know how to do synthetic division, you just do this. It's kind of like a division symbol, except it's upside down. Some people call it a hockey stick. You write the coefficients here of the original polynomial, so 4, 12, negative 1, negative 15, just like that. And on the outside, you put 1. So this 1 here, that represents dividing x minus 1. Okay, so you just put here whatever the actual root is, all right? Now, what do we do? Well, first thing you do is you bring down the 4. You do 1 times 4. 1 times 4 is 4, so you put it there. 12 plus 4 is 16. 1 times 16 is 16. 16 and minus 1 together make 15. 1 times 15, 15. Negative 15 and 15 make 0. So you can put a little line there if you want. This last term represents your remainder, and the first 3 terms represent the coefficients of your answer. And so because you have 3 coefficients, it's going to be 4x squared plus 16x plus 15, right? That last one doesn't have an x next to it. So that is your answer. It's the exact same answer you get using long division. We'll do more of this. We'll have another video doing synthetic and long division practice. So you can check that out, but this is the basics of that, okay? All right, let's do another example. Let's say you have f of x equals 4x to the 4 plus 7x cubed minus 80x squared minus 21x plus 270. So again, we have to use the rational zero theorem. I have to look at the factors of the last number, which would be plus and minus 1, 2, 3. There's a lot for 270. We're not going to write them all out. That's okay. Because again, we're just going to try to cross our fingers and hope that one of the simple answers is going to work, right? One of the smaller numbers. And then for 4, you have plus and minus 1, 2, 4. So then you divide the numbers on the right by the numbers on the left. So you'll have plus or minus 1 over 1, 1 over 2, 1 over 4, 2 over 1, 2 over 2, 2 over 4. That keeps going forever, right? Or not forever, but it keeps going for as long as you have, numbers to work with. And some of these numbers are repeated, right? Like really what you have here, 1 over 1 is 1, 1 over 2 is a half, 1 over 4 is a quarter, but then 2 over 1 is 2, 2 over 2 is just 1 again, so you don't have to write it. 2 over 4 is just a half again, so you don't have to write that one. So really some of these are going to repeat themselves. But hopefully one of these sort of easy numbers to calculate is going to be a root, right? And you don't have to go into the 2 advanced numbers, right? So let's just try some of these. Let's try f at 1. If you do f at 1, quick check here will show that that doesn't work. If you do 2, I don't think 2 is going to work either. Negative 2 might work, but let's try 3. Let's try positive 3 before we have to check a negative number, because again, you'll have 3 over 1, right? That's going to be one of them. So 3 over 1, you do f at 3, 4, 3 to the 4 plus 7, 3 cubed minus 80, 3 squared minus 21 times 3 plus 270. When you're checking these answers, you can just use your calculator, right? Because it's quite a bit of work to check. But if you do 3, I think this one's going to work, because you have 3 to the 4, which is 81 times 4, and then here you have 3 to the 3, which is 27 times 7, minus 80 times 9, minus 21 times 3, which is 63. Yeah, this actually is going to work. You're going to get 0. That's good news for us, right? You can say, therefore, x minus 3 is a factor, right? So you just want to add those together. If you get 0, good, we have a factor. Now, what does that mean? Well, it means that to find the rest of this, we have to use division. I'll just use synthetic division just to save some time. So you put the 3 here, you put the coefficients up here, 4, 7, negative 80, negative 21, 270, just like that. Bring down your 4. 3 times 4 is 12. 12 plus 7 is 19. 3 times 19 is 57. 57 and minus 80, you get minus 23. 3 times negative 23, negative 69. Negative 69, negative 21, negative 90. 3 times negative 90, negative 270. And of course, 270 minus 270 is 0. You better get a 0 here, otherwise it means we made a mistake. So that's good news for us. So that means that what we have left over here is 4x cubed plus 19x squared minus 23x minus 90, right? That's what these numbers represent. So we can't quite factor this on our own yet. So we have to find another factor and then do another division, right? So what's another factor we can use? Well, we already tried 1, 2, and 3. Negative 1 I don't think is going to work. Let's try negative 2, right? So, and the numbers here, 4 and negative 90, you should take the factors of those again. So 4, you have plus and minus 1, 2, 4, same as last time. But negative 90, you have plus and minus 1, 2, 3, that keeps going, right? So I kind of want to try negative 2, right? 2 over 1. I'll try negative 2. If you plug in negative 2 here, you get 4 times negative 2 cubed plus 19 times negative 2 squared minus 23 times negative 2 minus 90. So we're kind of doing a question within a question, right? We're doing that same process all over again. If you plug in negative 2 just like this, I believe it turns out to 0. Yeah, and then you could say, therefore, x plus 2 is a factor. So because x plus 2 is a factor, you can now divide x plus 2 out of this answer here, right? So we'll do another synthetic division. So we'll set it up like this. Because the root was negative 2, I'll put a negative 2 on the front. And then on the inside here, I'm going to put my coefficients, my new coefficients, right? 4, 19, negative 23, negative 90. Then we go ahead, bring down the 4. Negative 2 times 4 is negative 8. Negative 8 and 19, that makes 11. Negative 2 times 11, negative 22. Negative 22 and negative 23 make negative 45. Negative 2 times negative 45 is 90. Negative 90 and 90 make 0. So that's your remainder. You get 0 again. That's good. So now we have 4x squared plus 11x minus 45. That's what that represents, right? This is something we can factor by hand, right? We can use decomposition here. So to use decomposition, we do 4 times negative 45. That's going to equal negative 180. So you want to multiply to negative 180, and you want to add to the middle number, which is 11. Okay, I'm going a bit faster, but we should be comfortable with this stuff by now. So we add to 11. So how do we figure this out? Well, what I'll do first is I'll write down the factors that multiply to negative 180, right? So like 180 and 1, 90 and 2, 60 and 3, 45 and 4. If you divide it by 5, you get 36, 36 and 5. You can do 30 and 6. Can't do 7, can't do 8. We can do 20 and 9. And remember, one of these has to be negative because they're multiplying to negative 180. And so which of these combinations add to 11? Well, I think if you do 20 and 9, where the 9 is negative, that'll work, right? 20 minus 9 is 11. 20 times negative 9 is negative 180. That's how you find that. So 20 and negative 9. So you'll have 4x squared plus 20x minus 9x minus 45. We factor by grouping. You're going to take out a 4x. You'll be left with x plus 5. You take out a negative 9. You'll be left with x plus 5. And that'll give you 4x minus 9 times x plus 5. So that's this one factored. Now, we factored everything, so we can go ahead and combine it all together. So your f of x is equal to, the first factor we found was x minus 3, and then x plus 2, remember that? And then these ones here, 4x minus 9 and x plus 5. Now it's fully factored. Okay, great. So from here you can find the roots. X equals 3, x equals negative 2, x equals 9 over 4, x equals negative 5. Go ahead. And these all are of an order of 1, right? They all have a multiplicity of 1 because they all appear once. So let's put these down. Negative 5, negative 2, 9 over 4, 3, something like that. And they're going to cross at each one, so, and it's positive, so it's going up here. It's going to go like that, and then like that. So it's a fourth degree polynomial, right? It was, the very first term was 4x to the 4. So it's positive, so they're going up on both sides, and it's a fourth degree. So you have this 1, 2, 3, 4. So this is the most exaggerated, I guess you could say, version of a fourth degree polynomial with the most roots possible, right? And that's it. So hopefully you're comfortable with that.